Once again, we're going to look at graphs and solve equations from the graph. I have this very interesting looking, very new looking equation here, and this is actually its graph. You don't need to be able to graph this just now or yet. We've just chosen this funky looking shape because it's interesting to work with. You'll find that out in a minute. So don't worry about, us never having drawn these graphs before. It doesn't matter. It's given, right? This is the equation and this is its graph. So what we've done before is we're given an equation, we draw the graph, and then the types of equations that we've solved are where we set this equation equal to a constant. K is a variable that stands for a constant, which is just a number. Let's do some of those. And we have done this before. So what if we say this is equal to 3, right? So now I've chosen 3 as my constant. This is my new equation that I'm trying to solve. What would I do? I have this graph, right? I'm going to find out when is it equal to 3. So when does y equal 3? And I would grab my ruler and say, okay, that means I have to draw a line at y equals 3, right? And see where these lines intersect, and then this would give me the x value that makes this true, which is 1, 2, 3 and a bit, 3 1/4 around, right? And I could do that with all different constants, right? So that's why I've written this to summarize all those options. We could set it equal to 3 and draw our line at 3. We could set it equal to 6 and draw our horizontal line at 6, y equals 6, and find the solutions or roots to these new equations. If we look at, so this is our big equation where we can just plug in numbers for k. If I pick 3 as my constant, we've seen it hits there. There's one x value that makes that true. There's one root. So the x value is we call the root, right? The solution. The x value that is the solution that makes this true. We call them roots, don't forget. But what if I'd drawn my horizontal line? So what if I hadn't picked 3 but some different number? Say I chose 6. X squared over 2 minus 8 over x. What if I picked 6? And I've drawn it here. This is 6. If this were my horizontal line, how many times does that intersect with our original graph? Here it touches exactly at the tip of this shape, so it hits it once there and once there. So if I picked 6 for my constant, that would give me 2 roots. 3, picking 3, that was this line, gave me 1 root. Now can you think of a place where can you think of a number, a constant for k that we can plug in that'll give us even more than two roots? If you look at it carefully, you will see that anything above 6 gives us 1, 2, 3 roots. Everything above 6 gives us 3 roots. So for example, well, let's just plug in 10. that would give us 3 roots. So 3 values of x that'll make this equation true. That's kind of cool, isn't it? That there's actually 3 different x values that you can plug in that'll give 10 in the end. That's pretty cool. But our graph shows it, right? To summarize this information, you could say, if this is going to be our new equation, this is the equation of the line that we drew to begin with. If we set it equal to a constant, we can summarize it. If k is equal to 6, there are 2 roots. As you can see, if k is smaller than 6, so anything smaller than 6, it'll give 1 root, and everything bigger than 6 is going to give 3 roots, right? I think that's all I need to tell you. Yep. So you'll be given the graphs of different equations. Don't worry about them looking funny or the equations looking funny. All we're going to do is set them equal to a constant and then look at the constant and say, for which values of this constant, which is actually the y value, do I get 1 root, no roots, 2 roots, 3 roots, 4? And answer those questions. All right, have fun.